Hello, I will be presenting my final project for stats253, and my presentation was on statistical analysis of heart disease by me. So, first off, the data that I found is data of individuals and their medical conditions, and then we have a final target field that represents the presence of heart disease in them, and that's a rating from 0 to 4, and that's quantitative. And the data was collected in 1998 by a multinational team of researchers for the purpose of understanding heart disease. It was collected from Budapest, Switzerland, and the United States. So sort of what I wanted to do with this data was understand which medical predictors could be linked to the presence of heart disease in individuals. So we can sort of analyze what goes into heart disease, and also hopefully use the model as a preliminary test to help individuals know whether more research should be done into their specific condition. And the reason why I say that is because the target field, being a rating of heart disease from 0 to 4, is unclear because there are certainly many types of heart disease. So this should be viewed more as a superficial analysis to see the severity of heart disease in an individual, but once you get that rating, you should definitely go to a doctor to figure out exactly what your specific condition is, if any. So on that goal, the first thing I want to do is create a simple model that anybody could easily use themselves. So that's why I made the predictors for this model, specifically age, sex, chest pain, and max heart rate, which individuals should hopefully be able to measure and find out by themselves and plug into this model. And all it is a simple linear model here. So as you can see, all of the coefficients were positive except for max heart rate, which for me actually a little bit surprising. I would expect all of them to be positive, but this is what the model came up with. And we get an RMSE of about 0.04 with a standard deviation of about 0.1 or 0.11. And that's all right, but I kind of chose these variables at random, so maybe we could get a little bit of a better model here. So first let's analyze how, if this model was linear at all. So we look at these residual plots, and it's sort of hard to tell, for me personally, if there is any certain patterns here. I don't really see any. Maybe there might be a few, like you can see this one starts up, down, and then back up. You can see these blue lines do indicate some pattern, but you never really know. But I will get into this later. Okay, so yeah, here we are trying to figure out if we can identify more important predictors than those ones we kind of just chose at random originally. So I put all of the data into this backstep mod, and we use the 1SE selection function, and with that we find the simplest model with one standard error is this one with 4 predictors, specifically with chest pain, which is a measure from 1 to 4 of an individual's chest pain. It's quantitative. ST depression, which you can sort of see here, is a visual analysis of the an electrocardiograms, sort of visualization of a heartbeat. So you can see like it's sort of downslope, upslope, horizontal. Also major vessels, which is the number of major vessels that were colored by a fluoroscopy, and thalassemia, which is a categorical description of the level or the type of thalassemia an individual had, which is sort of a disease that changes your red blood cells, hemoglobin, which affects the amount of oxygen that can pass through your veins. and every predictor here was positive, and we got a much better RMSE here of about 0.86, down from just over zero point 0.1, and the standard deviation is about 0.17. So maybe this one is a bit more linear, hard to tell. Once again, it's just hard to tell. I personally don't see any specific patterns here, but maybe there are. You can see there's a bit of a downslope here. All of these are a bit under for the averages, but in my opinion, it mostly looks good. And then we want to see if we can identify maybe some more important predictors using a different technique. We already got those four that I talked about earlier, but let's try this lasso technique. So we also are using the one SE method. So the best regularization parameter, or lambda, was about here, which is just about 0.05-ish. And let's look at the results in the next slide. So we get quite a few more predictor variables, but this still the most persistent variables were the same four as in the back step selection, which were these four: chest pain, ST depression, major vessels, and thalassemia. And using all of these, we get an RMSE of about 0.88 with a standard deviation of about 0.12. So a bit higher are MSE, despite more predictors. So totally from these linear models, I'd say they're overall pretty good results. RMSEs were about between 0.86 and 1.03. And if you actually take the average of all of the target values and then take the RMSE of the model, which just predicts that average, you get about 1.23. So we definitely made a significant improvement from that, which is definitely good because we want to improve from just looking at the average. And it also helped us determine the most important predictors, these four, which we found twice using both the lasso mod and the backstep mod, which personally I think is super important. And then the residual analysis, once again, I was sort of unclear about it, so maybe a bit more further exploration would be helpful there, see if it really is linear, and we'll get into that a little bit here when we look at nonlinear models. So first off, the spline model, we maybe want to see if we could reduce the RMSE of our first models by introducing nonlinearity. So we do that on chest pain and ST depression. And we get an RMSE of about 0.86 with a standard deviation of about 0.08, which is the standard deviation is quite a bit better than before, but the RMSE is about the same. So let's actually check these residual plots again. For me, it looks pretty much exactly the same. You can see here maybe this blue line does dip a bit and straightens out here, but in general, the patterns, it just seems about the same. So for me, just looking at this, I would say everything seems to be linear, because the RMSE didn't really change all too much, and these plots more or less look the same, in my opinion. So let's try this in another way. Let's look at a GAM model. Let's plug in all of the data into this GAM model also. And when we do this, we actually get an RMSE of 0.85 with a standard deviation of about 0.14. And notice we actually use the best selection function here. And that's because if we didn't, we'd choose a span of 0, which would end up messing with some of our results. And instead, if we use, or if we used 1 SE rather, we would get this. But if we use best, then we actually get this one, which is about 0.95, which is better, and also it doesn't produce those errors of having a span of 0. I'm not exactly sure where that came from, but this ended up working, and it produced very similar results either way. And this is actually the best RMSE we found, of that about 0.856, and then the standard deviation was about 0.14. So let's look at all of these partials when you hold all the other predictors fixed. And what you can see here is that actually this is much more linear than I was expecting, which kind of proves the point earlier where maybe those things were linear. There's something like cholesterol, it does kind of do an up or a down, up, down motion. And something like age, there is kind of a curve there, but still pretty much very consistent linear results for most of them. And some of these are categorical, so those interpretations aren't exactly correct, but I'd still say it looks pretty good. I'm not going to go through every one of these because I don't really understand the medical implications for each of them, but for a lot of them, they do make sense. And then to summarize that, we got pretty okay results. RMSE is about 0.86 or about 0.87, and then remember that's a decent improvement from that average RMSE that was about 1.23. And then I think my favorite model would probably be about the 4-predictor spline model. Despite it not having the best RMSE, which was the GAM model, its standard deviation was the lowest, and it still had a pretty decent RMSE. And then we found general effects of predictors with our GAM, which I'd say is a huge success. We get to see how each predictor affects presence of heart disease. But still, we found some outliers. So is there maybe another way to look at our goal? So remember, one of our original goals was to use the model created as a preliminary test to help individuals know whether more research should be done into their specific heart condition. So in many cases, the difference between something like 1 and a 4 or a 2 and a 3 doesn't really matter because they'll still be going to the doctor with that result and figuring out exactly what their potential issue is with their heart. So what we can do instead is just convert that target field into, which was originally something from 0 to 4, into something binary, which is 0 if there's no presence and 1 if there's presence of heart disease, and then run a classification analysis on that new target field. So first we do this using logistic regression, and actually a lasso logistic regression model. So we're just trying to accurately predict whether an individual has some presence of heart disease, and we end up doing this pretty well. We get an accuracy of about 0.83 with a standard deviation of about 0.09. And this, we just use the same 4 important predictors that we found earlier. And then we did one other method using a tree model. So we want to see if maybe we could increase that accuracy. And I actually put in all of the predictors here, except for these 2 target factors, because I just created these because of the types. The data types needed to be different for this tree model, so I had to get rid of these ones that encoded that same information in them. And we ended up getting an accuracy of about 0.79 with a standard deviation of about 0.099, which is all right. It's a little bit worse than our last logistic regression model. But you can see here, actually, it's split on these on thalassemia, major vessels, and chest pain, which were 3 of the 4 most important from earlier. It's just missing ST depression. So continuing, so to summarize, I'd say this is actually pretty good. Remember, our best accuracy in that logistic regression model was about 0.83 with a standard deviation of about 0.09. And if you calculate the no information rate, it's about 0.46. So our accuracy was almost double that. And I Googled it, actually 0.48 of adult Americans will have some type of heart disease. So our no information rate is pretty close to that. And actually lower, which was surprising, because I thought that there might be some bias because they were collecting data from patients who are already in the hospital, but it turns out it's a bit lower. That could also have something to do with the fact that this was, the data was collected in 1988, and this information was from 2019. So for most people, I'd say this model, this using classification is probably more helpful than using regression. In the future, I'd probably like to use more types of models for classification, something like a random forest, and maybe explore different variable choices for what we use to predict. And then also maybe get a new data set with different predictors and maybe one that's newer and more up to date with current health trends. And that's everything I have to present. Thank you for watching, and also thank you for the great semester.